Hello, pre-calculusers. We are going to talk about radical equations and inequalities. This is very similar to the way you did it in Algebra 2. There are a couple of new things that we need to discuss, but on the whole it's pretty straightforward. They are radical if they have variables in the radicands, that is under the radical. Sometimes, just like in absolute value equations or rational equations, you can get a solution and you may obtain a number by doing everything right that does not satisfy the original. That's called an extraneous solution. You need to make sure you don't include those. Most of them will be like you did in Algebra 2. We'll do inequalities as well, which you may not have done, and we'll be doing some that we don't do in Algebra 2 anymore. So you've seen them in honors, but if you didn't take honors. So things like example 4 will be new. All right, so 1, 2, and 3 should be review. Example 1, time t, here's the formula, L is the length in inches, and they give you the period. So 2.5 equals 2 pi times the square root of L times 384. So what we want to do is solve for L. So first we divide by 2 pi. So 2.5 divided by 2 pi. Little tip for you, when you go to put this in the calculator, always make sure you do this. Otherwise it'll divide by 2, but then multiply by pi. All right, equals, and then the inverse of square rooting is squaring. So you square both sides. I'm actually going to leave it this way and only put it in the calculator at the end. But you don't have to. That's just the way I'm going to do it. Equals L over 384. Multiply both sides. And L equals 60.95 inches. I did a little bit of rounding. If you plug that in, you get roughly 2.5. That is very close to 2.5, but it's a little difficult to get it exactly. So, that's the basic deal. If you have a square root, you get everything away from it, if possible, and then you square both sides. So, example 3. Example 2. Solve this. Well, we cannot square this until we get rid of this. That is, we could, but if we tried to square this, plus 3, and multiplied it by itself, we would actually have to FOIL. We would do first and outer and inner and last, and we would end up with a mess, and we'd end up having to square it again. So you need, if possible, you want to move everything away so that all that's left on one side is the radical. If you can get it there, then you can square it. So squaring both sides, x minus 3 squared becomes x squared minus 6x plus 9, and over here the square root and the squared cancel each other out. You've just got x minus 3. Subtract the x from both sides, becomes x squared minus 7x. Add the 3 to both sides, you get plus 12 equals 0. Factor this, x minus 4, x minus 3, x equals 4, or 3. Indeed, if you plug it in, is 4 equal to the square root of 4 minus 3 plus 3? Well, that's 1. Square root of 1 is 1. 1 plus 3 is 4. Yes. How about 3? Is 3 equal to the square root of 3 minus 3 plus 3? 3 minus 3 is 0. Square root of 0 is just fine. Square root of 0 is 0. Plus 3 equals 3. So that works as well. There are 2 values for x in that equation. Now, when you're dealing with square roots, and we will only be dealing with real numbers, and that's a bit of a switch from last week. So we only want real numbers, and that means you have to look out for negatives. So if you have something like this, the square root of x minus 1 equals negative 3, you say there's no solution. There's no way to do that. If, however, you have cube root of x minus 1 equals negative 3, that's okay. Odd roots, you can have negatives, that's no problem. But even roots should not have negatives in the real numbers. So, we're going to subtract 3 from both sides. 4 equals negative cube root of x plus 11. Let's get that negative out of there by You can divide by -1 or multiply by -1. It does exactly the same thing. -4 equals cube root of x minus 11, and the inverse of cube root is cubing. That's -64 equals x plus 11. -75 equals x. Plug it in. -75 plus 11 is -64. Cube root of -64 is -4. 3 minus -4 is 7. So it works. By the way, if you go into the math menu, there is an option for cube root, so you can actually put that in. Now here's the bit that's troublesome. In a problem like number 4, there is no way to get the radicals, both the radicals, by themselves. This one has to be on one side or the other. So what that means is you're going to need to square it twice, which is not a problem, but you're going to need to FOIL it and be careful about what you get. That is a problem for a lot of people. So we are going to square both sides because that'll take care of the square root. That's no problem. X plus 1 equals. This is the problem. So let me show you what's going to happen here. 1 plus the square root of 2x minus 12 times 1 plus the square root of 2x minus 12. Do the outer by outer. 1 times 1 is 1. Then we get 1 times the square root of 2x minus 12 plus 1 times the square root of 2x minus 12 plus, and then the square root of 2x minus 12 times the square root of 2x minus 12 is 2x minus 12. At that point, you've squared it. But so this side is going to be 1 plus, now these are like terms, so we can add them together and get 2 square root of 2x minus 12, and then plus 2x minus 12. At this point, we've only got one radical. So if we can get everything else away from it, we'll be able to square it. So we're going to subtract 1. X equals 2 square root of 2x minus 12 plus 2x minus 12. We're going to subtract 2x. Negative x equals 2 square root 2x minus 12 minus 12. Then we're going to add 12. Negative x plus 12 equals 2 square root of 2x minus 12. Finally, divide by 2. I know this is a bear of a problem, but that's just the way it has to be done. So negative x plus 12 over 2 equals the square root of 2x minus 12. Now we can square them. All right. Remember that when you're squaring like this, this is the product property with exponents, you can split them up. So I'm going to come over here now. So the top will be negative x plus 12 squared. The bottom is 2 squared, so we can turn that into 4. Equals, and on this side the radicals disappeared, so it's 2x minus 12. So I'm going to multiply by 4. Negative x plus 12 squared equals 8x minus 48. And then I'm going to have to FOIL this out. So negative x plus 12 times negative x plus 12 is negative x times x is x squared. Negative 12x plus negative 12x is negative 24x plus 12 squared is 144. Get everything on the same side. So we'll subtract 8x. We'll add 48. X squared minus 32x plus 192 equals 0. Now this is factorable, but I actually ended up doing quadratic formula with it because I couldn't think of the factors, so if that works for you, that works for you. But it in fact does factor into x minus 24 and x minus 8. So x is 24 or 8. Now this is specifically the place where you run into trouble with these extraneous solutions, so I'm going to plug both of those in. Is the square root of 24 plus 1 equal to 1 plus the square root of 48 minus 12? Well, 24 plus 1 is 25. Square root of 25 is 5. 48 minus 12 is 36. Square root of 36 is 6. Is 5 equal to 1 plus 6? No. So 24 is what we call an extraneous solution. It doesn't work. We did everything right, it just doesn't work. So let's check 8. Is the square root of 8 plus 1 equal to 1 plus the square root of 16 minus 12? 2 times x, right? Well, 8 plus 1 is 9, so this side is 3. 16 minus 12 is 4, so this side is 2. Is 3 equal to 1 plus 2? Yes. So 8 works just fine. Inequalities. There is something special about inequalities, but this one doesn't show it. This one is really, really normal. We will simply square both sides. 6x minus 5 is greater than 16. 6x is greater than 21. X is greater than 21 over 6, or 7 over 2. Plug it in to check it. Graph it if you like. That works. So all values greater than 7 over 2 satisfy this equation. On the back, I'm going to give you the answers to the back. I would like you to do them on your own, and then you can come back here to check it. Number 6, t is equal to negative 3/4. Number 7, x is equal to negative 31. Number 8 is a special one. Number 8, the first step you would do is subtract 5 from both sides, and you get the square root of x minus 4 is equal to negative 3. And stop. We are working in the real numbers. Is there any number whose square, is there any real number, that is, any real number, x minus 4, whose square root is a negative? No. So there are no real solutions. Number 9, so long as each side only has a radical on it, you can square both sides and the radicals will disappear and you can solve it very simply. So for number 9, x equals 7 over 2, or 3.5 if you like. And that works very nicely. Number 10, this is another one of the weird ones. So you want to get them on separate sides. So I'm going to rewrite it this way, 7 minus square root of a minus 3. Now I'm going to square. This will be a plus 4, and over here you've got a FOIL, so 49 minus 7 square root a minus 3, 7 square root a minus 3. So this becomes 14 square root a minus 3 plus a minus 3 squared, which is just a minus 3. A plus 4 equals, well, let's combine these two, they're like terms, 46, bring this up front, plus a minus 14 square root a minus 3. We'll subtract 46, and we'll subtract a, and that's actually rather nice because the a goes away. This turns into negative 42 equals negative 14 square root a minus 3. That means 3, negative 40 should have negative 14. 3 equals the square root of a minus 3. Square both sides. 9 equals a minus 3. A equals 12. Plug it in. It works just fine. Square root of 16 plus the square root of 9 does in fact equal 7. On the bottom, this is the place where inequalities, where you do have to be a little tricky. Because this is a less than, we're going to have to look out for, we need basically to check the domain. So, we're going to solve it like normal, and then we're going to check the domain at the end. First thing will be to square both sides. 5x plus 4 is less than or equal to 64. 5x is less than or equal to 60. X is less than or equal to 12. That's all well and good, no problem. However, if we're working in the real numbers, then your radicand, the part under the radical, can't be negative, right? Because we're not taking the square root of a negative. So you say the radicand has to be greater than or equal to 0. So the smallest number x can be is negative 4/5. So the final answer here is negative 4/5 is less than or equal to x is less than or equal to 12. Anything below 12 will satisfy this, but anything below negative 4/5 will be imaginary. Imaginary numbers are not less than 8 or greater than 8 or equal to 8. They're different numbers. You can't Subtract the 3 from both sides, you get 7. Square it, 4a minus 5 less than or equal to 49. 4a less than or equal to 54. A is less than or equal to, say 13.5. But the thing under the radical can't be negative. Got to be greater than or equal to 0. So A has to be greater than or equal to 1.25. I know I did fractions here and decimals here, but sue me. There, you can use either one. So 1.25 is the lower bound for A, because below that, this becomes imaginary. And A has to be less than 13.5. The reason we didn't have to check the domain on example 5 is because if x is greater than 7/2, then 6x minus 5 is already greater than 0. But it certainly wouldn't hurt to check. Let's just double check. For this to be positive, x would have to be greater than or equal to 5/6, and 7/2 is already greater than or equal to 5/6. So that's why we don't have to say it. There you go.